Hello, this is Ben McGahee with McGahee Mathematics, and this is our third video on a system of equations where we get to learn a special algebraic technique called elimination. Elimination is a special method used to solve system of equations. It's where you eliminate one variable and then solve for the other variable. And then you can use substitution to plug that value back in to either one of the two equations to solve for the remaining variable. So I know that was quite a mouthful, but let's see how this works in practice with an example. So let's start out with a very basic example. Two equations, x minus y equals 7, x plus y equals negative 9. And then we'll draw a line underneath. Because something below this line actually happens where we're going to get just only one equation with one unknown. So the elimination process will start here. If you notice, we have x and y in both equations, but let's just say if we notice the coefficients of, let's do this in yellow. We have a negative 1 for y and a positive 1 for y. The coefficients for x are the same. But what if we did something like add the two equations together? If we add x plus x, we get 2x. Negative 1y plus 1y, or negative y plus y would be 0. We just have 0y equals 7 minus 9 is negative 2. So notice here that the variable that we eliminated was y, right? So this y actually goes away, and then we're just left with 2x equals negative 2, and then we divide both sides by 2. So x equals negative 2 over 2 is negative 1. So that was pretty easy, right? We actually eliminated the variable y, and then we solved for x. So x equals negative 1, and then now we can substitute x equals negative 1 back into any of the two equations. So we'll plug it back into, let's say, second equation here. So that way we have negative 1 plus y equals negative 9. So if we add 1 to both sides, ones cancel, and we're left with y equals negative 9 plus 1, that's negative 8. So our solution is x is negative 1, y is negative 8. And there's our final answer. Okay, so that's probably one of the most easiest or simplest problems of elimination, is if you just add the equations together, one variable cancels out. It's very convenient to use, but unfortunately not all systems of equations are that easy, right? You have some that are a little more challenging and require a little more thought to solve. So let's say, for example, if we have m plus 5n equals 15, and then we have 3m plus 15n. I'm sorry if my n's, they look like h's, and equals 30. Used to be when I was teaching community college, a lot of people thought, is that H, or it's actually an N. So I'll just treat that as an N. M and N. So M plus 5N is 15. 3M plus 15N is 30. Draw our line underneath. And in this part, we can't necessarily just add the two equations together. I mean we could, but it won't do us any good because there's no variables with opposite signs for one thing, and then also if we add the variables together, we see that none of the variables m or n cancel out. So we're going to have to use another strategy to eliminate at least one of the variables. What we do notice is that we have a coefficient of 1 for this m, and we have a coefficient of 3 for that m. So if I wanted to somehow cancel out these m's here, at 3m and the 1m, at this 3, I know I need a negative 3 to cancel out with that, because negative 3m plus 3m is 0. And that's my goal, is to try to cancel out the m's. So one thing I can do is I can multiply both sides by negative 3. So basically I'm multiplying everything in this first equation by negative 3, every term. So negative 3 times m, that's negative 3m. Negative 3 times 5n is minus 15n, equals 15 times negative 3, that's what, negative 45. And then we have 3m plus 15n equals 30. So let's see what happens if we add the two equations together. So we notice a couple of things that happens. Negative 3m plus 3m, that's 0m, so those cancel. Negative 15n plus 15n, that gives me plus 0n, so that cancel, equals negative 45 plus 30, that's what, negative 15, right? So on this side of the equation, everything cancels out. 0m plus 0n, or that's just 0, right? Nothing, basically. 0 equals negative 15. And it looks like we get an equation that's false, right? Or this is a contradiction. So 0 does not equal 15, because they're two different numbers. So whenever that happens, whenever you get one side is not equal to the other, you're going to say that the system has no solution. So the system has no solution. Because that doesn't make sense, right? You know, if you have 0 does not equal negative 15, or if you have 1 equals 2, you know, something ridiculous like that, there is no solution to the system of the two equations. Now, on the other hand, let's say if both variables did cancel out, and let's say you just got something like 1 equals 1, so both sides are equal. Or if you just had 0 equals 0, so the two numbers are the same, then you would have a solution. You would actually have infinitely many solutions for this system, because these equations, they're called an identity equation, where the two values on both sides of the equation are the same. So this would be infinitely many solutions. And it kind of goes back to that first video when we were talking about the coinciding lines, you know. This case would be for the coinciding lines, because you have both both lines are basically tracing over each other or the same value. But in this system here, where we had no solution, this was a pair of parallel lines, right, where they don't meet. So you can think of this case here, this equation, where we had no solution. That was a set of parallel lines, and then the one that had infinitely many solutions was the case of the coinciding lines, or the lines that trace over each other. So, okay. And so those were just a couple of problems that I wanted to show you with elimination. And now, of course, you can use this technique here that we did, where we multiply a number to both sides of the equation, and of course you will get a solution. Sometimes you have to multiply a number to both sides for both equations, you know. So say, like, for example, if you had 4p minus 2q equals 6, and then if you had negative 6p plus q equals negative 10. So let's say instead of eliminating the variable q, let's focus on eliminating the variable p. So if we focus on the variable p, we look at the coefficients. We have 4 and we have negative 6. So in this case, you kind of have to think about least common multiple, right, of 4 and, let's just say, positive value 6. Well, the least common multiple of these would be 12, right? That would be the smallest number if you were to count by 4s, and count by 6s. The smallest number they would have in common is 12. So what you could do is you could multiply, you know, both sides of this equation, let's say by 3. 3 times 4 is 12. And then for the second equation, since this is a negative, we need 12, we need negative 12, so we just multiply that by 2 to both sides. And see, you get the 3 times 4p is 12p, and then negative 2 times 6p is minus 12p. So you're going to see that the 12p's are going to cancel out, and then now you can solve for q. So you'll definitely have some system equations where you have to multiply by a number to both sides for both equations. And just in general, higher order systems like 3 equations, 3 unknowns, 4 equations, 4 unknowns, and higher, elimination is one of the best methods to solve for. And I actually use different things where you get to set up those equations in form of like a matrix, and we'll definitely talk about that much later on down the road when we learn about solving systems of equations by matrices. But well, this has been McGahee with McGahee Mathematics on systems of equations. Thank you for watching this video. Hopefully it's helped you out, and of course we'll be moving on to our next unit on polynomials, so stay tuned.